Welcome to today's lesson on kinematics. Kinematics is describing motion in relationship to time. Here we're not really concerned about what's causing the motion, just different ways we can express how that motion occurs. We're really focusing on displacement over time, so things like speed, velocity, acceleration. We're also looking at movements in the linear motion, but also angular motion. So today's lesson, we're just going to have a little overview of kinematics. We're not going to go in too deep because you could really go into the formulas and a lot of complex areas. So today's lesson will just be an overview of kinematics. Since kinematics involves a description of motion, let's look at some different types of motion. First type we have is translational motion. And if you look at the picture, that is when we're just moving from point A to point B. We're talking about that straight line distance. Now we might be moving in a curved line to get to point B, but still we're measuring that straight line distance. And the way we can track that movement is through our center of mass. Our center of mass in our body is right around our belly button, and we can change our levels of our center of mass depending on our body position. So we can use that to track translational motion or straight line motion. Then we have rotational motion, where we're moving around an axis. So in our body, we use our joints to do this. We're moving. So if I'm doing a bicep curl, my elbow joint would be an axis of rotation. Most of the time in sports or any activities that we do in our lives, we're combining both. Because, for example, we're moving from point A to point B, but we're also doing some different things. So if you're running down the basketball court and then you're getting ready to shoot, your joints are moving rotationally, or if you move around another person when you're moving down the court. So the combination of the two is general motion. So translational motion is point A to point B. Rotational motion is moving around an axis of rotation, such as a joint. So most of our activities involve general motion, which is a combination of both. Linear and angular kinematics are similar because they're looking at displacement over time. So we have linear displacement over time and angular displacement over time. So both areas can look at things like speed, velocity, acceleration. They're both extremely helpful because we can measure these things through stopwatches, timers, tape measure, measuring out the distance for something, looking at those angles. And through that study, the athlete and the coaches can get feedback on performance, so they can take that and look at how they might improve techniques and skills to help improve that performance. So it gives that feedback so the athlete or coaches can make changes in their sport or activity. For example, I might notice on video that a young athlete isn't truly running in a sprint. They're not running in a straight line. They're fading a little bit to the right or the left. And we can measure the athlete's time beforehand and then make some changes in the running technique and see if that improves the time, and give feedback whether the changes were effective or not in technique. The formulas for linear and angular motion are similar because they both involve changes in properties over time. So linear motion, you're going to look at linear properties like the distance. Angular motion, you're going to look at the angular displacement and radiance. Now, one thing to look at is when we look at speed versus velocity, they seem like, if you look at the formulas, they seem the same, but the subtle difference between the two is speed is just straight distance over time. Velocity is displacement over time. So there's a direction to it, or a magnitude to velocity. So it's a subtle difference. Again, speed is just going from point to point. Velocity might involve change of position. So it's a little bit different. In summary, kinematics is a description of motion in relationship to time. There's some different types of motion. We had translational motion, which is point A to point B, rotational motion, which is around an axis of rotation. But most activities involve both, so that's general motion when you have the translational and rotational motion. There's linear and angular kinematics, which means, again, those straight line versus angle motions. Both of them you can look at speed, velocity, and acceleration. These measurements are helpful because they give feedback to athletes and coaches on whether their skill and technique is effective. So it helps with performance and also injury prevention. Again, if we're doing things correctly, we're less likely to be injured in those situations. So think about kinematics in your mind. Take your sport or activity and determine how would kinematics help you, or help you again with your performance or injury prevention in your sport or activity.